This is going to be limits part 6, and we're going to be going over piecewise limits. So limits part 6, piecewise limits. Just to review, if you don't remember what a piecewise function is, it's a function that has two different formulas to tell you what the graph should look like. So for example, actually, well, you'll see a piecewise function in our first example. So example 1. Let's say we have f of x equals 3 minus x and 2 minus x. So it has two different things that it could be, but it's only 3 minus x when x is less than 1, and it's 2 minus x for every other number, which is x is greater than or equal to 1, or we could have done not less than 1, but I think greater than or equal to 1 is a little bit easier to put. So let's draw a graph of this. So we have 3 minus x, so if we plug 0 in for x, we would get a point here at 3. So we'll call that 3 for the y value. And then, let's see, let's plug in 1 because that's the biggest point we'll go to. So 3 minus 1 equals 2. So when x equals 1, this is going to be at 2, so we'll put x equal 1 there, and we'll call this 2. Now notice this is not equal, so it goes up to that point, and we can tell from the look of this that it's just going to be a straight line, so that equals this right here, and we'll do this at 2. Then let's look at our next portion of it. We have, whenever x is greater than or equal to 1, we graph 2 minus x. So at x equals 1, it would be 2 minus 1, or 1. So we have that point there. Let's just plug in 2. If we plug in 2, it'll be 0. So x goes to there, and we can also tell this is going to be a straight line. So the drawing isn't very good here, but these should be lines of the same angles. And let's say we want to find the limits. So find limits at, we'll say as x approaches 1 from the left and the right. Let's see. How can we do this? We know from x approaching 1 from the left would be right here. So limit as x approaches 1 from the left of f of x. We aren't going to write down this whole formula in here. Equals, let's see. As x is right here and it gets closer and closer to 1, it also gets closer and closer to 2. And then we can do the same thing as x approaches 1 from the right of f of x equals, let's see here. As x starts here and gets closer and closer to 1 from the right, it gets closer and closer to y equals 1. So that's our limit there. Let's go on to 2 more examples. So example 2. Let's say we have g of x equals x squared for x is less than or equal to 1. And it equals 2 when x is greater than 1. The first thing we need to do is draw a graph. Most of us know the x squared graph, which looks like this. So that would be x squared, but we only want to go up to 1. So let's redraw that. and say this is 1 right here. So we'll have 1, 1. So this point goes on forever. And then once we have x is greater than 1, we have the value 2. So let's say if 1's right there, 2 would be about right here. And we would have a open there because x doesn't actually get to this point. So that would be our graph. And we can look at the graph to find the limits. So limit as x approaches, we'll find the limits at as x approaches 1 again. So the limit as x approaches 1 from the left is going to 1. So limit as x approaches 1 from the left of g of x equals 1. And the limit as x approaches 1 from the right, so we would start here and get closer and closer to 1 from the right, which gets us closer and closer to y equals 2. So g of x equals 2. Notice it's actually 2 all the way. That doesn't matter, that doesn't matter, and it just leaves our limit the same there. Let's go on to one final example. In this one we're going to work a little bit differently, but we could work the same way. Let's say we have g of x equals 3 plus x for x less than 2, and it equals x minus 1 for x greater than or equal to 2. Let's say we want to find limits as x approaches 2 from the left and right. Well, we could do this by drawing a graph, but I think it's a little bit better to also know how to do this mathematically. So let's do from the left first. Limit as x approaches 2 from the left of g of x equals, let's think about what this would look like, or how we would do this mathematically. Whenever x is less than 2, it must be approaching 2 from the left. So let's draw a little picture. So if we have some kind of weird graph here, in x, oh, that's the wrong side there. We'll have 2 right there. Whenever x is less than 2, it would be approaching from this side. So we would plug 2 into this formula to get our answer. So that equals 3 plus x, which is 3 plus 2, which is 5. So the limit as x approaches 2 from the left of g of x equals 5. And we can do something similar for the right. Let's say limit as x approaches 2 from the right of g of x. So let's think about what this would look like. We have the number 2 here. We have some kind of weird graph that we don't actually know. Well, we could figure out what it looks like, but we'll pretend we don't know. And we start to the right, and we get closer and closer to 2. Well, the right is when x is greater than or equal to 2. So we would plug 2 into this formula right here. So that equals 2 minus 1, which equals 1. So the limit as x approaches 2 from the right of g of x, I drew that in the wrong order. Limit as x approaches 2 from the right of g of x equals 1. So these are our answers to this one. And you could have done the first or second one mathematically without actually looking at the graph, and you could have done the third one with the graph. And these graphs do not represent the formula written, just as a reminder.